Hello everyone. Today let us discuss about numerical problems of electrostatic potential. Now, here we have different topics in potential. Potential due to a point charge, potential due to a dipole, and potential energy of a system of charges. Potential energy of a system of charges, again in two cases, in the presence of electric field, in the absence of electric field. Like that, so many topics are there. But I have taken a very simple topic of electrostatic potential. In the coming videos, we will also discuss about different numericals. Now, these three numericals I have taken for today. As I told you in most of my videos, to do the numericals, the first thing you should know is to by heart the formulas. That is, whatever the formula required for the numerical, you should know them by heart. If you don't know them, you have to learn them. How you will learn? Just take all the numericals and see what are the important formula required to do the numerical and write them in a notebook. Each formula you write five times and close the book and write again. If you are unable to write, again open the book, study them, again close the book, write them 5 times. Definitely you will learn the formulas. And now, using some formulas which are related to this topic, let us see what are the formulas. Let us see. Now, potential difference is equal to work done by charge. So, V is equal to work done divided by charge. This is one formula we will be using. Number 2, potential due to a point charge at a distance r from the charge. That means if Q is a charge at a distance r, we have a point P, then the potential at P because of Q, V is equal to 1 by 4 pi epsilon naught Q by R. This is another formula which we will be using. And after that, because of a dipole, suppose if we are using a dipole, so in that case, the potential at a point due to a dipole, you know a dipole, no? Already I have explained in my other videos about a dipole, potential due to a dipole. A dipole means two equal and opposite charges separated by a distance, that is plus q and minus q. They are separated by a small distance to a, that's called as a dipole. Then potential due to a dipole at any point, V is equal to 1 by 4 pi epsilon naught P cos theta divided by R square. That is also we can write, because it is a dot product, we can write as 1 by 4 pi epsilon naught P bar dot R bar divided by R cube. Like that also you can write. Where P is the dipole moment, P is the dipole moment which is Q into 2A, where P is the dipole moment which is Q into 2A, R is the distance from the point P, from the center point of the dipole to the point P where we want to find the potential. So, if you take any dipole, then from the center point you can select a point P. So here AB is our dipole, for example. Okay, from here we have selected a point P. From the center point, the distance of the point P, that's called as R, and it makes an angle theta with the direction of the dipole moment. Dipole moment is always from minus q to plus q. So this is what the terms which I am explaining. P is equal to Q into 2A, where 2A is the distance between the two charges plus Q and minus Q, and r is the distance of the point P from the center of the dipole, and that r bar, that is vector, makes an angle theta with the direction of the dipole. So like this you can learn the formulas. So three formulas we have taken, and then with this we can start our numericals. Yes, so this much is enough for you now to do the numericals, which I have written on the top. So let's go to the top. Now you can see the first problem: determine the potential at the surface of gold nucleus. The radius is 6.6 into 10 to the power of minus 15 meters, and the atomic number Z is equal to 79. Given the charge on the proton is equal to 1.6 into 10 to the power of minus 19 coulombs. So this is the first one which I am taking. This is the first problem which I am taking. What they asked is to find the potential at the surface of a gold nucleus, and then they have given the radius of the gold nucleus and the atomic number of the gold, that is Z is equal to 79. So why they have given the atomic number is whatever the number of the atomic number, that will be equal to the number of protons, and that is also equal to number of electrons. Therefore, if atomic number is 79, there will be 79 electrons and 79 protons will be there in this gold nucleus. Therefore, total charge Q is equal to N into E, that we learnt in the previous chapter. That is, N is equal to number of protons or number of electrons, which is 79 in this case, and the charge on one proton is equal to 1.6 into 10 to the power of minus 19 coulombs. So here what they have given is charge on one proton, they have given in the problem, that is E is equal to 1.6 into 10 to the power of minus 19 coulombs. So we have substituted it here. Therefore, Q is equal to Ne is equal to 79 into 1.6 into 10 to the power of minus 19 coulombs. That is the charge. Now, radius of this gold nucleus 6.6 into 10 to the power of minus 15 meters, and now let's calculate the potential, that is V is equal to 1 by 4 pi epsilon naught Q by R. So this already I have written here. So here I have written. So this is the formula which we are using here to calculate, that is V is equal to 1 by 4 pi epsilon naught into Q by R. So with that formula we will calculate the potential now, that is V is equal to 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. Q means just now we got 79 into 1.6 into 10 to the power of minus 19 coulombs, and divided by R, that is 6.6 into 10 to the power of minus 15. And I'm not simply calculating here because calculations will take quite a long time in the YouTube. So directly I already calculated. I'm writing the answer: 1.7 into 10 to the power of 7 volts. So this is the answer for the first question. Then let's go for the second question, because we have to save the time also. The second question which we are taking here is this one, that is electric field intensity at point B due to a point charge capital Q kept at a point A is 24 newtons per coulomb, and the electric potential at B due to same charge is 12 joules per coulomb. Calculate the distance AB and also the magnitude of charge Q. What they have given here is there is a point charge Q. How much is the charge? They did not tell us. But what they have given from the charge capital Q, there is a charge, there is a point A, and there is also another point B. And in the problem, if you observe carefully, they have given at A, they have given the electric field at A they have given, that is 24 newtons per coulomb. And there is also another point B. At B they have given, that is potential, which is 12 joules per coulomb. They asked us to calculate the distance AB, and then they also asked us to find the magnitude of the charge Q. So let's go and start, and then here we can also add one more formula, that is relationship between electric field and potential, which is useful for us now, that is V by E, that is potential divided by electric field is equal to distance R. This can also be used now because this is the relationship between potential and the electric field due to any charge. So now let's go for the second problem, that is second problem. First let us see what all they have given. They have given the electric field at the point A, that is 24 newtons per coulomb, and the potential at the point B, that is 12 joules per coulomb. They have given it. Now what they asked is, means I just give you a rough idea. This is the point Q, and from Q there is a point A here, where we have to find, where they have given the value of electric field, and we don't know where the point B. Just randomly I'm taking another point B somewhere. Okay, so let's take, this is the point B here. Let's assume this is the point B here. There they have given the potential value. Now what we have to find here is distance between A and B. What we have to find here is now distance between A and B we have to find, and also the related be R. And so R is equal to question mark, and the magnitude of the charge is also question mark. This is what we have to do now. Now let's write now. Let's take the E, that is electric field is equal to, we know from the previous topics, 1 by 4 pi epsilon naught Q by R square, which is 24 newtons per coulomb, and the potential at B, at the point B, V is equal to 1 by 4 pi epsilon naught Q by R, which is 12 joules per coulomb. Now therefore from this formula, which I have written, marked with yellow color here, V by E is equal to R, that is the relationship between potential and electric field. So this formula we will use, which is in the yellow color, and then find the distance first between the points A and B. That is the distance between the points A and B. You can see the distance between the points A and B is R. So let's, sorry, I'm getting extra lines. So let's write R is equal to V by E, that is V is 12, E is 24, that is 1 by 2, that is nothing but 0.5 meters. So now we got the answer, first answer, and they also asked us to find the magnitude of the charge. So for that, you can take the potential V is equal to 1 by 4 pi epsilon naught into Q by R, which is equal to 12, which they have given in the problem, joules per coulomb. That is what they have given. So from there we want Q. So you can rewrite this formula. We can rewrite this formula. Q is equal to V into, send all this 4 pi epsilon naught to the left side. You will get Q alone will be left one side. Then Q is equal to V into 4 pi epsilon naught R. Okay, so now you can substitute all the values. V is 12. You know 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9. So now here we got 4 pi epsilon naught. Therefore 4 pi epsilon naught is equal to 1 by 9 into 10 to the power of 9, reciprocal of that. So in place of 4 pi epsilon naught, you can write 9 into 1 by 9 into 10 to the power of 9 into, then after that 12 already we wrote, and then distance r is equal to 0.5. Distance r is equal to 0.5. So 12 into 9 into 10 to the power of 9 into 0.5, because the value of r is equal to 0.5. So therefore after simplifying, so you will get 0.667 into 10 to the power of minus 9 coulombs. After simplifying, you will get this, because if I do the calculations on the in YouTube, it may take quite a long time. So already calculated answers I am writing here. It's a simple calculation. You can also easily solve it, because 12 and 9 are the multiples of 3. With that you can easily simplify this one. So here we got the two answers. R is equal to 0.5 meters and Q is equal to 0.667 into 10 to the power of minus 9 coulombs. So for this we have used the formula. We have used this formula. The relationship between V and E, that is equal to V by E is equal to R. So with this we have solved our second problem, and then now let's go for the third problem. This is the third problem. Two charges, 3 into 10 to the power of minus 8 and 2 into 10 to the power of minus 8 are located 15 centimeters apart. At what point on the line joining the two charges is the electric potential 0? Take potential at infinity to be 0. So these are the two charges separated by a distance of 15 centimeters. Now we have to find on the line joining them at which point the electric potential is 0. So for that you can use this same formula which is in this green color, and then we can add them using the superposition theorem. Superposition theorem means you can add the potentials due to multiple point charges. Suppose if there are n charges, we can have the potential as V is equal to 1 by 4 pi epsilon naught. This is due to multiple charges. Sigma I is equal to 1 to n Qi by Ri. That means sigma means you all know summation. It is a summation. So you can find the potential due to individual charges, and you can add all of them. So the total potential is nothing but it is the potential due to multiple charges, that is adding all of them. So another formula we can use here like this. It's nothing but summation, superposition theorem. So what with that we can go for our third problem. Okay, so let's write the third problem. Here we have two charges. The two charges are separated by a distance of 15 centimeters. So let's take this is Q1, this is Q1, and this is Q2. Q1 and Q2 are the two charges. So the distance between them is 15 centimeters. So 15 centimeters means 15 into 10 to the power of minus 2 meters, that is 0.15 meters. So the distance between them is 0.15 meters. So this is what they have given in the problem. And they have also given in the problem that Q1 is equal to 3 into 10 to the power of minus 8 coulombs, and Q2 is equal to minus 2 into 10 to the power of minus 8 coulombs. Now, what is the question is, at one point, we don't know where is that point. At one point joining them, where let us say that is a point P here, the potential is 0. So let us take it as A, let us take it as B, the potential is 0. Let us assume that the point P is at a distance of x from A, So therefore, from the point B, it is at a distance of 0.15 minus x. Okay, I'll write again neatly. Okay, so now from the point A it is x, then it means from the point B it is 0.15 minus x. So this is the distance from the point B, that is from the charge Q. So adding the superposition theorem, we can add them. So you can see potential is 0 at the point P. Then we have taken the point P at a distance x from Q1, and from a distance 0.15 minus x from Q2. Find out the potential due to both of them and add both of them and equate it to 0. Here we have assumed that the point P is between A and B. So let us start now. Let the figure be here. So you can see potential due to the first charge Q1, that is V1, is equal to 1 by 4 pi epsilon naught Q1 by R. R means here it is x, that is 1 by 4 pi epsilon naught 3 into 10 to the power of 8 divided by R means x here. And then potential due to the second charge Q2, that is 1 by 4 pi epsilon naught Q2 by R, the distance, that is 1 by 4 pi epsilon naught, and second charge is minus 2 into 10 to the power of minus 8 divided by, here the distance is 0.15 minus x. But according to the problem, the potential at the point P is 0. So what we will do now, add both of them. V1 plus V2 is equal to 0. That is given in the problem only. So add both of them. We will get 1 by 4 pi epsilon naught 3 into 10 to the power of 8 by x plus 1 by 4 pi epsilon naught minus 2 into 10 to the power of minus 8 divided by 0.15 minus x is equal to 0. Equate both of them, add both of them and equate it to 0. So you can also write like this. Send this second term to the right side, because it is minus, it will become positive. Here it is minus, you can see. So minus, when it goes to the right side, it will become positive. Therefore, we will write 1 by 4 pi epsilon naught 3 into 10 to the power of 8 by x is equal to 1 by 4 pi epsilon naught 2 into 10 to the power of minus 8 by 0.15 minus x. Now you can cancel out whatever that is common in both the sides. 1 by 4 pi epsilon naught 10 to the power of minus 8 and 10 to the power of minus 8. Everywhere we have to put minus 8 only, because this charge is minus 8 here. You can see this is minus 8. This is also power to the power minus 8. So substitute minus 8 and then it will be cancelled out. And what remains here is now 3 by x is equal to 2 by 0.15 minus x. Now take the cross multiplication. 3 into 0.15 minus x is equal to 2x, and after simplification you get after simplification you are going to get x is equal to 0.09 meters. This is what you will get. That is nothing but 9 centimeters. So this is the answer which we got. That means the point Q, I'll show you the picture which I have drawn. This is the picture. The point P is at a distance of 9 centimeters. Yes, 9 centimeters from the point A, that is the first charge. Total distance between them is 15 centimeters. Therefore, from B it is 15 minus 9, that is 6 centimeters from the charge Q2, that is the point B. Now, not only this, sometimes in competitive exams, they may give you a different answer which is not here. How is it possible? I will tell you how you can solve it in the other way also. In this case, we will imagine that the point P is outside the line joining them. Outside the line joining them means I'll draw here. This can be the point A and this can be the point B, and extend the line. So the point P is outside them, outside of the line joining them. So here it is Q1, here it is Q2, and Q1 is 3 into 10 to the power of minus 8 coulombs, and Q2 is minus 2 into 10 to the power of minus 8 coulombs. And then now distance between them, as usual, like earlier we know 0.15 meters. It is meters, not centimeters, it is meters. And then let us assume this point P is at a distance of x from A, then up to here, that is A to B, it is 0.15 meters. Therefore, from B it can be at a distance of, from B it is at a distance of x minus 0.15. See, from A it is at a distance of x. A to B it is 0.15 meters. Therefore, from B to P it is at a distance of x minus 0.15. So once again, when the point is outside, now also we will add V1 plus V2 is equal to 0, Already we have done v1, v2 here. You can see here. But only thing is now the distances will change. Earlier the distances were this is x and this is 0.15 minus x, but now it will be slightly changed. From a it is x only, from b it will be x minus 0.15. That is the only difference you will get now, and the remaining all will be the same. So let us do that. That is 1 by 4 pi epsilon naught 3 into 10 to the power of minus 8 by x is equal to 1 by 4 pi epsilon naught 2 into 10 to the power of minus 8. Now this is the only difference, x minus 0.15 you will get here, and cancel whatever that is can be cancelled on both the sides. 1 by 4 pi epsilon naught both the sides, 10 to the power of minus 8 both the sides. Now you will get 3 by x is equal to 2 by x minus 0.15. So take the cross multiplication and then continue and simplify. Once you simplify, now you will get x is equal to 0.45 meters, that is equal to 45 centimeters. So this is the answer when the point lies outside. So in this way we can solve the problems. Same problem we have solved in two ways. One time the point P lies between A and B, or the other time the point P lies outside A and B. So when you have taken the point P in between A and B, here you got the answer as 9 centimeters. When you have taken it outside, you got the answer of 45 centimeters. So in this way we have solved the third problem using the same superposition theorem. Superposition theorem means here I have written that is here V number 5 I have written 1 V is equal to total potential 1 by 4 pi epsilon naught sigma I is equal to 1 to n Qi by Ri. So this is the fifth formula which I have used, and learn the formulas very well. And if you know the formulas, it is very easy to calculate the numericals. So take care, and appropriately you should have the idea like what is the main formula for that. Then once you know that formula and you think about which formula is best suited, and that formula you apply to the numerical, and easily you can solve the problem. So in this way you can solve the problems. All the best. We will meet with some more numericals in the next video. Till then, bye. God bless you all. Bye. See you all in the next video.